Hi, summertime chemists. It's Jamie. I am your summer school chem teacher. You're seeing this video during a slide deck assignment. And the gist of this video is going to be me making a bio-based plastic out of cornstarch in my kitchen. And then I'm going to test that plastic for its strength and compare it to plastic that our grocery bags are made of. So again, this video you're going to see me make bio-based plastic from the ingredients that you saw in a video in this week's Nearpod, and we'll go over those ingredients in a moment. You're going to see me make the plastic and then test the plastic, and then that'll create a little data set for you all to work with next week. Okay, so let's get started with these ingredients. So the first one that we have is the starch, the corn starch. This is a natural polymer. It comes from corn plants that grow in fields. And the natural polymer is made up of a whole bunch of monomers. And those monomers happen to be simple sugars. And so the corn plant strings all these simple sugars, all the monomers together, and they make a polymer, and that polymer is called a starch. Okay, so that's going to be the base of our bio-based plastic. The other things that you're seeing here are a cup of water. The water will be used to loosen up the polymer strands in the cornstarch. The next thing that you see here is vinegar. The vinegar breaks some branches. So the natural polymer has branches on it. It happens to be a fancy word called amylopectin. That's the specific name of the starch. And the vinegar goes in and it cuts off the branches of the amylopectin, leaving you just amylose. So that's what the vinegar does. Then we'll be adding glycerin. Glycerin is what makes the bio-based plastic flexible, like our grocery store plastic. A little bit of food coloring, and then just some measuring tools. We'll need tablespoons and teaspoons. Tablespoons and teaspoons. So you'll see me mix these things together. Then I will put it on the heat on the stove. After that, I'm going to put it in the oven, and then it'll be ready to test. Hi chemists, it's Jamie. In the last video, you saw me making bio-based plastic in my kitchen. And that is the first part of the experiment, is to actually make samples of bio-based plastic. The second part of the experiment is to test it, right? To test the strength of the plastic that I made. The dependent variable then becomes plastic strength. The independent variable is the type of plastic. So conventional plastic versus bio-based plastic, that's the independent variable. It's the thing that I purposely changed or manipulated. The dependent variable is going to be the strength of these two plastics. For conventional plastic, I'm just using a grocery bag. And in a couple moments, you'll see me cut this up into strips. And I'm going to pull it until it snaps and take a measurement. Here is yesterday's bio-based plastic. So after it came out of the oven, this is what it looks like. Feels pretty slimy. It's thin in places and thick in places. Here's like a whole glob of it. You see how thick that is? And so we'll see how strong this is compared to how strong this is. And remember, the big picture here is plastic waste, right? These plastic bags, they've become a problem because when we put them in the oceans and when we put them in the landfills, it's taking hundreds, sometimes thousands of years for them to fall apart. And so entrepreneurs, business folks, scientists, engineers, they need to figure out how can we make bio-based plastic and how can we make it good enough, right? Strong enough, thin enough, cheap enough, so that we can replace the grocery bags with the bio-based plastic. That is preferable because when bio-based plastic goes into the landfills or it goes into the oceans, microbes can eat it. They can eat the glycosidic bonds. Those are those weaker carbon to oxygen bonds. And if the microbes can eat it, then they can break it down. And that is better than all of this conventional plastic. Okay, so you're gonna see me, there's gonna be a time lapse. You'll see me cut up both the bio-based plastic and the conventional plastic into 6 strips each. 6 strips each. I'm gonna test it 6 times. This is better science practice than if I just did 1 trial. 1 trial would be super easy, right? I could get back to my summertime. But to be a better scientist, I should do 6. And really, the scientists who are working in the academies or the entrepreneurs that work in their businesses, they are taking thousands of trials. They don't mess. They don't mess. But we're going to do something in between. We're not going to do just 1 trial. I'm going to do 6. Okay. I'll see you on the other side of this video.